Hello everyone, my name is Tino van de Kraan and I work at SassyBot Studio. And today I want to show you how you can use Unity's pathfinding in a 2D game. To understand how this can be beneficial for your game, I want to show you a little demonstration. In the demonstration you can see small black characters being sent back and forth, making use of Unity's pathfinding features. The cool thing about this is that it makes use of dynamic obstacles, so you can see how the navigation agents are being pushed around by a dynamic obstacle, so the pathfinding mesh, the navigation mesh, gets updated dynamically. Let's jump into a new project and see how we can set this up. For starters, you do not want to make use of Unity's 2D viewport, and later on in the tutorial I will demonstrate why. First we need something for our agents to walk on top of, so we generate a quad in Unity and we scale it upwards. Then we rotate it 90 degrees so that it's perpendicular to the y-axis. Reset the transforms to put it in the center of your scene. Let's go to a perspective view. Alright, so this is going to be our plane to navigate on. Then we want to create an obstacle. So our obstacle will be this cube, dead center, like that. So in order to generate a navigation mesh, we will need to do the following. Select the cube and select the surface and mark them as static. Then in navigation you hit bake. Then it asks you whether or not you want to save the scene. Yes, we do. Let's call this navmesh for the time being. Mesh there. And you see a navmesh generated. And now for some scene organization, we will name things. So the cube here is going to be obstacle, and the quad is going to be floor. Alright, that's looking fine. So now that we have our floor and our obstacle, we need to have some sort of object that goes back and forth, or that uses this surface as its navigation floor, if you will. So we're going to create another cube, put this into the view, and this cube, just for clarity's sake, we are going to make red. So I've already created a material, but I'll just make a new one so that you know how that works as well. Create material, we call this green. Let's make the cube green. Then we assign this material to that cube, and when we click on it and go to the inspector, we see a new material here called green. Let's also make it green. Okay, so what we want to do now is give this cube some physics so that it will fall onto this plane before it starts working. So let's add a rigid body. It already has a box collider so that it will know when it collides with this plane, because the plane has a mesh collider. So now when we hit play, the cube should fall down and we should just be able to have fun with the cube. But we want to have the cube, or the let's just call this zombie. Every game needs zombies. Alright, so this zombie needs to head towards a non-suspecting victim. Alright, so this is going to be the victim. So we have our zombie, we have our victim, we have an obstacle. So now we need to tell the zombie where to go, and for this we need a navigation agent. This will allow it to interact with the nav mesh that we've generated. It will tell the zombie where it can go and cannot go. But the zombie still doesn't know where to go yet. It only knows where to go and where not to go. For this we need to write a script. It's a fairly simple script. I'm not the world's best coder either. but we'll just go through it step by step. So we hit, when selecting the zombie, we hit add component, we create a new script, and let's just call this zombie. Okay, the script is created. Now we will open the script editor. There we go. And give it some instructions. So first, the zombie needs something to go towards, and we want to make this a variable, a public variable, so that in Unity we can assign it where to go. So public variable, let's call this target point, or we can also just call it victim, to be honest. Victim, and the victim is a transform, like this. If you need to know how what words are where and how to make things work, there's an extensive scripting reference library online. Just search for Unity reference, and you can find what all this does. But for the sake of this tutorial, I will just continue writing this down. Then we also need to store the navigation component. So we'll make this a private variable. We don't need to interact with this in the Unity inspector. So private variable, let's call this nav component, and this is the navmesh agent, and that is, you can see it here on the zombie. This transform thing, that is the transform component, and the navmesh agent is the navmesh agent component, which you can see here as well. Transform component navmesh agent. So we have created those slots, a public slot and a private slot. Now in the start function, this will be run when the game is started, if the script is turned on. In the start function, we need to assign the nav component. So we have the nav component, and this will be referencing to itself, to its own transform, and inserting the component that is on the game object. So get component navmesh agent. So what this does is it will get the navmesh agent on this game object, put it in the variable nav component so we can reference to it later. Now in the update function, we need to say, we need to do an if statement. So if the victim is true, so usually if something is true, you just write it down like this. If something is not true, you write it like that. So if there is a transform called victim, so if that is present in the variable, we want it to do something. So what we want it to do is tell the nav component, so this thing over here, we need to tell it where to go. So we need to say set destination. And all this can also be found in the scripting reference. I've looked this up beforehand so that it will not take too much of your time. But you can find all this online and find out exactly what it does. Position. So what this does is it says every frame, if there is a victim, so if there is something in the victim variable, tell the nav component to set a new destination to the position of the victim. Oh wait, this is not target point, this is victim. So if there is a victim present, set the destination to the position of the victim. So let's save this. It's already attached to the zombie component, and you see here there is a slot available. So we want this to be the victim. So with the zombie selected, we drag from the hierarchy into this open slot. And what it will do is it will find a path towards the victim. And you can even see this, you see that it behaves quite well towards where the obstacle is. So I will demonstrate you why this doesn't work with the 2D pipeline or the new 4.3 or Unity 4.3 pipeline that Unity introduced, why it won't work. And for this I need to flip everything towards the 2D perspective, just for the sake of demonstration. So we create a new game object, and I will just rush through this so that we can get to the point quite quickly. We need to have the floor, obstacle, victim and the zombie in the same game object, and we flip this 90 degrees. Now we go towards the 2D plane, and you see that this is sort of the perspective that you would work in a 2D workflow. However, if you now hit play and you look at the navigation mesh, it is stuck there, and you cannot fix it by rebaking the navigation mesh. So if I click on the floor and the obstacle and want to rebake this navigation mesh, you see that it doesn't work. Even worse, it will simply create a navigation mesh on the top, if you will, on the Y plus axis, and that can be used. So the problem with Unity 4.3 is that for 2D games it does not support what axis you want to use for your navigation. So a way around this is to just ditch the 2D pipeline or the 2D work perspective, and go back to having Y as the up axis. So let's rebake this. The next thing that we want to do is have this obstacle be dynamic, because you can see that if I scale this down or if I move this, the obstacle will not update, and that is something you saw in the demonstration I gave you, and that is what I will teach you. So how to do this? We go into the inspector of the obstacle, and we give this a navigation obstacle there, and in order to make this cut into the navigation plane, we need to set this to carve. Now I believe if I rebake this, I'm not quite sure, if I rebake this, it should do what I want it to do, or maybe I should select them both. Let's see. Alright, so what we do have is that the navigation mesh is automatically updated, but the old one won't refresh. Oh yeah, that is because this is still set to static. In order to do static navigation meshes, you will have to mark it as static. So now with both selected, we rebake, and you will see that this is now a dynamic obstacle, and we can put this to the test by messing around with the zombie. Even better yet, you can make a duplicate. Mess the zombie up quite well. And the reason why this is messing up is, well, I'm not exactly sure why it is messing up, but I know how to sort of fix it, and that is increasing the navigation plane. So let's rebake this, if it will let me. Why won't it let me rebake this? Ah, there it is. So floor and obstacle rebake, and on a larger surface it should work from what I've tried. So let's see if this works. I duplicated the obstacle, and now I'm gonna have fun with the zombie. It's still sort of messing about. Oh well. Another thing that I want to show you is that you can just duplicate the zombies a few times, and then you have several zombies that you can annoy the hell out of. But if you mess around with it too much, it tends to bug out. Weirdly enough, with the demonstration scene I've made, it does not do that quite often. Another thing I want to show you to conclude this tutorial is how to add 2D sprites to this environment. So for this we need to create a, or first we need to add a sprite to the scene. So let's just make new zombies. This is the sprite I've added. And because I dragged the sprite straight into the hierarchy, it will assume that I want to work in the 2D perspective, which I don't. Let's call this new zombie, because this is like the new generation of zombies. We don't need that game object either, because that was just used to rotate the entire scene around. Let's go back to a top-down workflow, and we flip this new zombie 90 degrees. There we go. I will assume this perspective for the moment, because if I go to a orthographic perspective, you won't be able to see the what is what, to be honest. Actually, I could just give them different colors to differentiate them. I still have a material lying around. I showed you how to make materials, so you should be able to do this yourself as well. Let's make another material, and this is like a blue. This is the victim. Alright, so now we see what goes where a bit more clearly. So now we want to turn this into the zombie, and because Unity does not support pathfinding on 2D sprites, we need to envelop this in a cube with colliders and everything. So doing this, we go to cube, or we create a cube, we zero this out again, and then we move this on top of the new zombie that we just created, and make sure that the zombie is like completely in there. There, should be fine. So what we do now is, for this cube, we call this the new zombie container, and we add the new zombie in there. Because we can't see the zombie, we do want to see the zombie, we simply turn off the mesh renderer. So now we still have the benefits of the box collider, but we don't have it rendering the box. Now we want to add the same behavior to this guy as we did to the cubes, and you might have guessed, we add the navmesh agent and we add the zombie script. We don't add the rigidbody because we don't want it to fall on top of the surface there. We don't want to have physics on the new zombie. However, you can do it though, but I think it will look kind of goofy. So let's continue with adding a sorry, what was I saying? Oh yeah, navigation mesh agent, and we want a script. This is the zombie script, and if all is right, this should work. Which it doesn't. That may be because the does it have a target? Let's see. Oh yeah, I see what's wrong. I assigned the components to the sprite and not to the box, and we need to assign it to the box, to the container, to new zombie container. So we add navigation agent and we add the zombie script zombie. There we go. This should work. Yeah, it does. It just doesn't have a victim target yet. So if we assign a victim there, you see that it starts running around. And the navigation agents have a front and a backwards, so it will always try to face towards the victim. The other zombies have been going pretty crazy. Let's remove the old zombies because we have new zombies, and new zombies are so much better. So let's create an army of these zombies and see what happens. Oh yeah, I forgot to, when you add things in the inspector during runtime, it will not remember them, so keep that in mind. I need to reassign the victim as a target. So there we go. Now all the zombies are following the victim. And you see that the jitter is also gone. I'm not quite sure what's causing it, but I do know that this has solved it. So this is how you go about creating navigation meshes for 2D sprites, basically. In this example, we have used particular 3D assets, but these can just be sprites as well. Just do the same approach as with the zombies. You create a game object, an object with a 3D collider, and just put your sprites in there. You can use scripts to lock the perspective of the zombie so that they will always be facing upwards. And now you can make the zombie harass game. So as a closer, we're gonna have an army of zombies. Follow the poor, poor victim. Brains. So if this tutorial has been useful to you, please consider subscribing and following, because there will be more tutorials, not only video tutorials, by the way. We also keep a blog on sassybot.com/blog. Additionally, you can discuss this tutorial or request other tutorials by following me on Twitter, or talking to me on Twitter, which is the tag TinoVDK. Thanks for watching, and I hope this has been useful.